Radhe Radhe everyone. I am guessing that I am audible. Just wait for a few minutes. I have to set up this. Like I think I am streaming after a quite long time, so things look a little bit different. The UI has changed, I guess. So yeah, this looks good, I guess. Do okay. So this is goal. I don't know what the heck is this. I'll host XYZ. Okay, this is the one. Okay. See what I'm trying to do is I'm just waiting for a few people to join so that members only stream. Schedule your live to switch to members only. Wow, wow, this is nice. But no, not an issue. अभी के लिए सब कुछ free है. ठीक है. अभी के लिए सब कुछ free है भाई साहब. Okay, so okay, first of all I have to check whether I'm audible perfectly or not. Let me check that. Okay, there's a noise that is coming from a background, so I think that is because my laptop is. There's a noise that is coming from a background. Now I think I will be better audible. So let's start with today's lead code contest. Okay. Don't see that. Okay. So lead code weekly contest 472. The first question. Drum rolls. It is the smallest missing multiple of k. You're given an integer array nums and an integer k. Return the smallest positive multiple of k that is missing from nums. Okay. Your multiple of k is a positive integer divisible by k. So this is a very simple question. Okay. So it is telling us that you are given a number k. You're also given an array. So you have to find the smallest multiple of k that is missing in the array. Okay. In simplest terms, find the smallest multiple of k that is missing in the array. What you can do is you can loop out through 1 to n. Okay. 1 to n and check like k, then 2k, then 3k, and so on till you can check till nk. Okay, or rather n plus 1k. Sorry, my mistake. N plus 1k. You have to check. Okay, the first number that is not there in the array, you can directly say that that is missing. Okay, there are a lot of ways to do it. You can do it any ways. Any way you'll find it better. You can use a hash set, you can use a hash map, you can simply go for a big O n squared approach, up to you. Okay, I have gone for a big O n squared because it was given that the constants are 100. So why should I even code that much, right? So I went for that. So you can look into the solution. Okay, I'll just show you the solution. Okay. Anyways, like so, what happened to the live stream, man? I think it's because that I'm coming live after a long time, so not much people over here, which is okay, not much of an issue. Anyways, I'll just spin it. Wow, that's so class solution. I mean, this is a solution that I have coded. It is that you are going to traverse from 1 to n plus 1. I just told you k, k plus k, 2k, 3k, and so on. You can go on doing it like that. And then int f is equal to 0. For int I is equal to 0, I less than n, I plus plus. That is, you are going to traverse throughout the whole nums and check if that multiple of k is there in the nums or not. If it is there in the nums, then okay, we can't do anything. But if it is not there, then f is equal to 0. Okay, so then we can return x. Otherwise, return -1. This is not much of this doesn't make sense because we never come till over here. Okay, we never come over here. Okay, so any problem, guys? Anything that you want to understand again or something like that? Okay, so any problem, guys? Anything that you want to understand again? I think I think my screen is lagging a lot now. Must be some settings issue. I forgot to set, I guess. Just a minute. I'll just set it up. Because see, the drop frames are 0 only, but the FPS is lagging somehow. And the FPS usually lags when there is some CPU intensive work going on. Okay. But now I think it is okay. It is good, I guess. Okay. So let me just continue with the whole thing. Okay. So we are done with this question. Let's move on to the next question. The next question tells us that you have to find the longest balance of array 1. You're given an integer array nums. A subarray is called balance if the number of distinct even numbers in the subarray is equal to the number of distinct odd numbers. Return the length of the longest balance subarray. Very simple. This one is also a very simple question. It is okay because of the data structures you are giving it as a medium, but if you look into it in a very casual manner, it's a easy question. Okay, it's not that medium level question. What you can do is, I'm really thinking that okay, now it is okay. So what basically this question tells us is that you're given nums, okay, you have to find the longest subarray where the number of distinct even numbers and the number of distinct odd numbers are same. Okay. Now how to do that? You know that if you want to store something distinct, something unique, there are two types of data sets, data structures that we can use mainly. One is the set. I made it sit. One is a set, and the other is the map. Okay. Now I won't restrict you to use any one of them. I mean, I won't restrict you to use specifically any one of them. You can use any one of them. Okay. You can use set or map. I have used set because I think map takes up a lot of space. Set is a little less heavy. So what I can do is I can traverse through all the subarrays and check what is the number of distinct even numbers and what is the number of distinct odd numbers in it. If it is equal, then I can consider that it can be an answer. It can be a possible answer. What do I mean by that? See, very simple code, not that huge line of LOCs. So I'm taking the length of nums, answer, and traversing throughout the whole thing. This is the starting point, I. Okay. And for every starting point, I'm having two sets. One is for even, other is for odd. Okay. Now I'm going to traverse from the starting point till all the ending points. Okay. And I'm going to check if it is even, then add it to set 1. If it is odd, add it to set 2. Okay. And if at any point the size of set 1 and set 2 is same, that means the number of distinct even numbers and number of distinct odd numbers, they are same. In that case, we can directly say that we can consider it. So answer is equal to mat.max j minus I plus 1. What is j minus I plus 1? It is nothing but the length of that subarray. Okay. So that is the length of the subarray. I'm really I don't recollect like how I used to do this, but this issue I have already fixed this. this lagging thing, but I really forgot like how I fixed it. Just wait a few minutes before going to see. I'll just check if I can do it now. I think you can do it only before you start streaming. The thing is that I even have forgotten like what it was. I think if I stream in 4K, then this thing gets. I think I was streaming earlier in less than 4K, and I think today. Oh, okay. I used to stream in 720p, I guess. Yeah. Now I'm streaming in 1080, so that is the reason I think it's happening. So this is also very temporary effect. Like it is not that. Oh come on, man. Entry level job market is cooked. Leave it. Just bear with me. Okay. So let's move on to the third question. Oh, this one. Oh, I think because of this or what? If I remove this, yeah, the stream gets better, no? The stream gets a little better. Okay. Lexicographically smallest permutation greater than target. You're given two strings S and target, both having length n consisting of lowercase English letters. Return the lexicographically smallest permutation of S that is strictly greater than target. If no permutation of S is lexicographically strictly greater than target, return an empty string. A string A is lexicographically strictly greater than a string B of same length if in the first position where A and B differ, string A has a letter that appears later than that in B in the alphabetical order. Okay, very simple. I think the question I don't have to explain. So, anyways, I'll just explain it quickly. Can I change the settings over here? Can I change the settings over here? I should have done this before starting with question C only, but just wait now. I think this is getting problematic for me also and you guys also. That is, the stream is getting unplugged. See, the thing is that if you look into this, see, only 0.1% has been dropped. Okay. Now, look into over here. Encoding overloaded, consider turning down video settings. So, This is the issue. Okay, I think I'm streaming at a very high quality, and I'm also not sure whether I can downgrade it. Problem D, I couldn't do problem D. I've done till C only. I was looking into problem D, but from the hints that I am seeing, I don't think I was doing it the right way. Okay. Okay. Till the thing loads, I'll tell you what this question tells us. This question basically tells us that you have to make a permutation of S such that it is the smallest permutation of X that is lexicographically, sorry, yeah, it is the smallest permutation of X that is lexicographically greater than target. Okay. You have to find out a string which is strictly greater than target, but that should also be the lexicographically smallest permutation of S. Okay, clear? Well, let's try to understand now the language. The language is you have S. See, when I'm telling it's an array, it's not an array, it's a string, but a string is basically a character array only. So this is S and this is target, and both of them are of same size. Okay, one more thing, both of them are of same size. Okay, now if you want to, can we solve D using other simple techniques? See, I'll tell you what I have done. Okay, first of all, I tried with using a greedy approach. That is, the whatever I was doing for B, I was doing for D also, and then checking that whether do I need to check till a specific position or not. Okay, that is, let's say I'm already getting the answer as 5, so I won't be checking for length 5, right? I will be checking for length 6 from now on. So that was what I was doing. That gave a TLE 2, and the approach was also not that good. I felt it that okay, this is not a valid approach. In the worst case scenario, it's the same thing. Then I tried doing binary search, that is the number of even numbers, number of distinct even numbers. See what, whenever we are taking a subarray, so we are having a number of distinct even numbers and a number of distinct odd numbers. Now, if we can, in a binary search, if we can fix that, so that is, we are going to check for 5 even numbers and 5 odd numbers. No, not possible. Let's say L is equal to 1 and L is equal to 0, L is equal to 1 and R is equal to 11. Okay, or rather 9. So what is mid? Mid is 5. So check for even, 5 odd. Not possible. Go a little bit lower. But you know what? This is a policy. It doesn't mean that if 5 is not possible, 6 won't be possible. And it doesn't mean that if 5 is not possible, 4 will be possible. So in binary search, you have to come up with something that if 5 is not possible, then 6 will also be not possible. Then we will go for lesser. But this was a little bit tricky. So binary search won't work for this. I'll explain you what I have done when I will be explaining D. Okay. First of all, let's focus on C. Now S and T. So we have to make S lexicographically smaller but greater than T. A permutation of S. Okay. So what we can do is, instead of having it as S, we can have a frequency array for it. Because you know what, like if you're checking for permutation, so the order of S doesn't matter for us, right? So we can have a frequency. Now that we have a frequency array, you know what, like if you want to make something greater than T, so what you can do is you can have a greedy approach. Go from left to right and check if this element is there in frequency, well and good enough, put it over here. This element is there in frequency, well and good enough, put it over here. This element is not there in frequency, right? What will you try to do? You will try to make this element greater. Okay, this element you will try to make greater. So this and this you have already done. This element you have to try to make greater than this element. Okay. Now how to do that? You can check for all the other elements which are greater than this. I mean all the alphabets which are greater than this in the frequency, and if you find that any one of it has a frequency, put it over here, and the remaining part you just sort the remaining of frequency. Okay, because you have already attained the lexicographically greater than T string in the smallest way that you can have. Okay. Now there is a little bit of unique case in this. Okay. This will work. Okay. One more thing. That is, what if I just now I said that the over here you have to put the element which is greater than this and present in frequency. Let's say this is B. Sorry, my mistake. This is B and frequency has all A's. Okay, all of them are A. So you can't put anything over here, right? If there was a C, you could have put C over here. But there is no C. All of them are A. You can't put it. So now you have to backtrack. You have to remove this element. Okay, remove this element, and let's say this element was a C. Okay, this element was a C. So now this becomes C. And check, is there anything that we can do about it? No. Now again we have to backtrack. Go to over here. What is this? Let's say this is B. So now we get a B out of here. Is there any element greater than B in the frequency? Yes, C is there. So now we have to replace this with C. Okay. And the remaining can be in the ascending order. A, B. Okay. Clear? Now this is, everything is fine. Okay. We have got it. What if S and T are same? S and target are same. That is a unique case that we have to handle. But I don't know, I have handled it. There may be some other way to do it also, but I have done it by handling it separately. So what I have done is, if S is equal to if S is equal to T, so in that case I have to find the next permutation of S. If that is the last permutation of S, return empty string. If that is not the last permutation of S, return the next permutation of S. Okay. Let me go through the code and explain you what I have tried to done. So this is 300. Okay. So one thing to notice, you didn't need to do any optimization. You can just simply go for whatever technique you are thinking of. Lexicographically liberator. First of all, I'm converting it into a frequency array. I just explained it. Then I'm having an answer. This is the return. Like I just told you that I like putting strings in the form of character arrays always, because that is easier for me to access it in Java. In C++, you can directly access because it stores that only like that. But in Java, there is string pool concept. So we have to be a little bit careful about that. So for int I is equal to 0, I less than n. So I'm traversing throughout the whole thing. I'm checking the character at that specific position. If the frequency of that character is greater than 0 in S, then I can directly say that I can put that character in answer of I. Okay? And frequency of CH minus minus, because I'm taking it out from frequency. Continue. If it is not so, okay, if it is not so, then what I have to do is I have to check for all the characters, all the alphabets that are greater than that element. That is from CH plus 1 till 26. If any one of them has a frequency C greater than 0, then I can put it over here and I can make the frequency C minus minus, that is whatever I was doing over here, nothing different. Then I have to put a fill, that is, I just told you, once you have put it over here, the remaining part you have to just fill with this in ascending order, right? So I am just going to fill in the ascending order. What I am going to fill in the ascending order, I'll let you know. Okay, I'll let you know the fill function in the later part, and then I can return the string directly. What if none of the conditions satisfy? So I just told you, we have to backtrack. Backtrack from I minus 1 to greater than equal to 0, and check for every frequency, put it back into the S, into the frequency array, and then check if any element greater than that element is there in the frequency or not. If it is there, the same thing. Put it into answer, frequency C minus minus, and fill. The same thing, okay, the same thing. Same thing comes over here also. No change in code. Just the fact that we have to backtrack and then go for this. Okay? Then go for this. Otherwise, you can return empty string if none of the conditions happening. This won't happen basically, but sometimes, you know what, like the code gives throws an error that there is no reachable return or that thing, those stuff, those errors. So just, is it annoying at first but got it later? Oh, you got D later or C? I actually forgot to look into the comment section. I think I'm streaming after such a long time, so I'm just even forgetting what are the settings that I used to do and stuff like that. Okay. Okay. So now if new string, that is the answer, if it is equal to target, I just told you what we have to do in that case. We have to return the next permutation. Okay. Even this was not needed, but the same thing, return, that will be returning something. This was not needed because we know that if it will be always target. If it is not target, then we would have returned it over here only directly. Now if ns dot equals this, then return next permutation. Now look what I am doing for the fill. The fill is ch is equal to 0. I have to set it with a only. 0 means a, okay. And then I have to go from start till end, and I have to check if ch less than 23, that is it's the alphabet, and frequency of ch is equal to 0. Then ch plus plus. Go to the next alphabet because the frequency of that has exhausted. If that is not exhausted, put that into answer of I and try to reduce the frequency of that by 1 because we are just putting it from frequency into answer. Okay. The next permutation function is very simple. Like if you haven't come across kind of questions like this, next permutation, then it will be a little bit unique for you to understand. Otherwise, it's simple. I'm taking the length of the array. I'm checking if I greater than equal to 2. Okay. I greater than equal to 2 and I mean N greater than equal to 2 and an air of I greater than equal to air of I plus 1. Okay, so if that is the previous element is greater than equal to the second element, then we have to go on traversing. Okay, we have to go on traversing I minus minus. That is, we have to go on traversing one by one step at the back. Initially, it would be I would be starting from n minus 1, right? Sorry, I can't do it. I can override. Initially, this would have been starting from n minus 1, but we start from n minus 2 because we are checking for I plus 1. Okay, clear? If I less than 0, which means that this is the maximum permutation that we could have got. That is, everything is in descending order. Okay, then in that case, return the empty string because this is the maximum. So there is no next permutation. Otherwise, j is equal to n minus 1. J is a right pointer. While AR of j greater than equal to AR of I, j minus minus. So we have to find out the specific ith position that we are at right now. That is not that is the first position that is breaking the descending pattern. Okay, the first position that is breaking the descending pattern. We can replace this with the last position. What last position? The last position which is greater than that position. Okay. See, this is lesser. This would be going like this, right? This will be going like this. Ith position I plus 1 and then till j it will be going like this, right? So you have to find the first element that is greater than this and you can swap them. Okay, you swap them and then you reverse the whole thing till end. Okay, that is what the next permutation does basically. Character is air of I, swap air of I and air of j, and then reverse from I plus 1 till n minus 1. Okay, you do anything, this is the best solution to find the next permutation. So I hope this is having no issues. I'll move on to D, but in D there is the same thing. Okay, the same question as what? As in B, it is the same question. Okay, what is the difference? The difference is in constant. Okay, the constant tells us that it is 10 to the power 5. I won't be explaining the question B, D again because it is same thing as B. I'll be just going directly through the hints. Okay, I don't have the code also. Okay? I'm just being very much honest. I don't have the code. I haven't coded it. I couldn't do it. Okay, please tell how to solve problems seen most Leetcode contests. It depends, man. It's nothing like there is no rocket science. I mean, sorry, there is no specific hard and core rule for it. Okay, so let's try to understand deep. It is telling that store the first or all occurrences of each value in position of value. Strange. Let's try to go to the solution. Easiest solution with example explanation. Acha, lazy segmentation. So lazy segmentation means like segment tree is always needed. If there is a solution without segment tree, I'll explain it. Otherwise, I'm not a huge fan of segment tree. That's the segment tree. Okay, so we can skip this solution. If you guys want to go through the solution, you guys can check this solution. But I am really very much weak with segment trees. Okay, I'm really very much weak. So let's skip this session and directly go to the 1.6% TLE case. Only 1.6% acceptance rate. Ah, is it so? How do I see that acceptance rate? But anyways, if people are telling that it's 1.6%, then it's 1.6% only. But then how many were there in the AK? How many all killed were there? I don't know. Leave it. Let's read the problems quickly. You know, Sunday mornings I get it. And anyways, tomorrow you guys must be having some leave or holidays, right? So happy Diwali in advance. Easy, hard, medium. A was easy. Medium will be having two parts. Okay, two parts is more. B will be a lower medium. C will be a very tricky medium, and D will be hard because it was using segment. Rather, if I could divide the hard into two parts, then D will be coming in the upper half only. Because you know, like segment tree is a data structure which I feel that it should be like, it is like good to understand it what it does, but I'm not that much of a fan of segment tree. Okay, so that's it, guys. Thank you for joining. Have a good weekend. I mean, already it's a weekend. Have a happy Diwali. So that's it. Thank you. Bye.